Hello, dear students. In this, the lab practical related with the gas welding, we'll be talking about the various practical aspects of the gas welding. So, the main objective of this practical is to demonstrate the procedure of the gas welding, to impart the information on consumables and the various gas welding system components, and to demonstrate the different types of the flame in gas welding and how these are realized, and to communicate the fundamentals, working principle, application, advantage and the limitations of the gas welding process.
Hello, dear students. In this video, we'll be talking about the gas welding and its the setup and the methodology how it is done. So, in general, the process is called oxy-fuel welding, which can be used for cutting, joining, and the brazing also. So, the principle used here in this process is very simple, where one fuel gas, which may be in form of propane, acetylene, hydrogen or similar kind of the gas is used, and it is mixed with the oxygen to have a combustible flame, and that flame is used for the purpose of heating the base metals in case of joining so we need to supply both oxygen as well as acetylene, and both are mixed in a particular proportion in order to get the flames of the different types, so that they can be used for joining as well as cutting as per the kind of metal which is to be processed. So, if we see, this is the torch which is which will be used for the cutting purpose, and here we can see there are two pipes. The one you can see, one is blue and another is red. The one which is red is for the supply of the acetylene or fuel gas, and the blue one is for the oxygen. And here both will be fed, and in this mixing chamber both will be coming, and the proportion of both the gases can be adjusted using these two control valves. Okay. So, you can see here one is coded with the blue and another one is with the red. So, these knobs are in order to adjust the supply of the oxygen as well as the fuel gas, and that mixture of the oxygen and fuel gas will be coming through this nozzle outside, and then using this kind of the lighting system, it gives the spark. So, the fuel gas mixture is burned, and then through the adjustment of these knobs, by changing the proportion of the oxygen and acetylene, suitable different types of the flames are produced. And most invariably, the gas welding can be autogeneous or it can be with the help of filler. So, if the filler is to be used, then filler is just like simple steel which is copper coated in order to avoid the rusting, and so the fillers of the different sizes and the diameters can be used as per the need of the joining. Okay. So, as I have said, that oxy-fuel gas system can be used for the joining, brazing as well as cutting. So, here if we see, this is the you can say the tabular data about the kind of parameters which should be used for oxy-fuel cutting or oxy-acetylene cutting purpose of the different types of the steels. So, these are mainly structural steels which are cut. So, you can see the steel plates of the different thicknesses, the kind of nozzles that nozzle sizes that are to be used, like 1 by 32 inch, 3 by 64 likewise. So, these are increasing diameter of the nozzle, so that your the flame size is bigger and it is able to deliver more amount of heat required for the preheating of the steel while cutting. And you can see these are the kind of oxygen pressure which is used for the cutting purpose. You see, once the preheating part is over, kindling temperature has been attained, then we supply the oxygen jet so that oxidation can take place and exothermic reaction results lot of heat generation, that in turn facilitates the melting and cutting of the plates. So, this is just a broad guideline for cutting the different steel plates using the different oxygen pressures and the nozzle sizes. So, here we can see in this is the list of the different items that we need for the gas welding or the cutting, like it includes acetylene cylinder, oxygen cylinder, which are the main gases for oxy fuel cutting or welding. Okay. Then oxygen regulator, acetylene regulator, acetylene hose pipe, which is used for taking the acetylene from the either cylinder or from the source to the nozzle. Similarly, the oxygen hose connection, acetylene hose clips, which are used for tightening purpose, then oxygen hose clips, blowpipe set, cylinder key, and then a spark lighter to ignite the oxy fuel mixture, and the gas welding goggles to protect the eyes from the radiations as well as the sparks, and the wire brush for the cleaning purpose, and the tongue for handling the plates which are to be joined. In this the practical demonstration will be showing how to develop the gas weld joints in procedural way. What will be the first step, what will be the second step, how to develop the different types of the flame and how do they look like. So, now we will show the demonstration of the gas welding process. So, here we have fired the flame using the spark. So, now we will show that how by adjusting the control valves we can change the different types of the flame. Okay. So, this is like say the one type of flame where you can see just the two coals. Okay. One is the outer one, which is considered as a low temperature zone, and another one is the inner one. Okay. Now, show the different types of flame first. Okay. This is neutral flame. Okay. Now, carburizing, can you switch over to carburizing? Okay. Yeah, so here you can see there are three flames. One is the outer, then intermediate, and then the inner cone. That's very clear. So, the intermediate feather or the flame is an indicative of the proportion of the acetylene. If we keep on increasing the proportion of acetylene, then intermediate feather will keep on increasing in length. Okay. Now, we will show the like neutral flame. You can go for the neutral flame. Okay. Now, it will show the welding, how procedurally we can do the welding. Okay. In one side we have filler, another side we have flame. This is at 45-degree angle of both the torch, the flame, you can say flame axis, and the filler axis. Okay. So, initially for the welding using the flame, we will be preheating the plates to be joined. Once the preheating is done to the enough high level temperature, wherein little fluidity is established along the edges, the filler wire is fed in the flame zone. Both are almost at 45 degree. Okay. This is the preheating stage. Once the preheating part is over, the filler is fed, and then both the flame as well as the filler are moved along the weld line to complete the joint. and you need a lot of skill in order to control the feeding of the filler as well as proper manipulation of the flame, so that there is a equal distribution of the heat and at the same time desired penetration is also realized. So we'll keep on feeding the filler wire along the weld line. You can see that both are inclined at a certain angle, which is usually 40-45 degree, and here in this case the torch is pointed in the direction of welding, so that is suggesting the forward welding. In this case, the base metal to be welded is preheated by the flame itself. That helps to increase the welding speed as well as the penetration. And when the torch tip is inclined in the direction opposite to that of the welding, then we say backward welding. And in the backward or backhand welding, our post heating of the weld joint or weld metal is realized. That helps to relieve the residual stresses as well as soften the weld joint. So this is how we can see the steel plates have almost been joined by the gas welding. So on cooling, we can see the kind of the weld bead profile and the condition of the penetration. Okay. So you can see the tongue is being used to manipulate, adjust the welded plates. Okay. And the smoothness of the bead profile to a great extent depends upon how effectively in control way the filler and the flame is manipulated during the welding. That's all from the demonstration side of the gas welding process. Thank you very much.
Gas welding. Gas welding is a welding process that melts and joins metals by heating them with a flame caused by a reaction of fuel gas and oxygen. The most commonly used method is oxyacetylene welding due to its high flame temperature. In this video we will cover the following about gas welding, equipments of oxyacetylene welding, working, advantages, disadvantages, and application. Gas welding equipments. Cylinders. In gas welding, there are two cylinders. One is of fuel gas and is of maroon color. The second one is oxygen gas and is black color. Oxygen and acetylene are stored under pressure in a steel cylinder. They are seized by the amount of oxygen or acetylene that they hold. Cylinders should always be secured and used in the upright position. When a cylinder is not being used, the valve cap should always be in place. Oxygen cylinders. They contain compressed oxygen at high pressure that can be as high as 2200 psi. All cylinders have valves and are fitted with a screw-on steel cap that protects the cylinder valve when the cylinder is not in use. Acetylene cylinders. These cylinders contain acetylene under pressure, made of steel and have cylinder valves. The cylinders contain porous filler material, which is fitted with acetone, that allows the acetylene to safely be contained in the cylinder at 250 psi. Acetylene should never be used at a pressure that exceeds 15 psi, as it becomes highly unstable, which depending upon the condition could cause it to decompose and explode. Pressure regulators. For welding, the oxygen and acetylene are required at low pressure, but in the cylinders, they are filled in high pressure. So a pressure regulator is required to control the pressure of oxygen and acetylene before reaching the mixing chamber. Torch. The torch consists of the handle, oxygen and the fuel gas valves, and the mixing chamber. Inside the handle, there are tubes through which the oxygen and fuel gas flow. Mixing chamber. In this chamber oxygen and fuel gas are mixed. In this mixing chamber, the ratio of oxygen and fuel gas is mixed according to the type of flame required, such as neutral, oxidizing or carburizing flame. Control valves. There are two control valves available in this torch. One is for the oxygen, and the second one is for fuel gas. These control valves are used to control the flow of oxygen or fuel gas to the mixing chamber. Gas hoses. The gas hoses are used to transfer oxygen and fuel gas from the cylinder to the welding torch. These hoses are color-coded for easy identification. This color coding varies from country to country. Nozzle. The mixture of oxygen and acetylene comes out of this nozzle. The mixture of these gases comes out in pressure from the nozzle and then is ignited by the striker. Goggles and gloves. In gas welding, goggles and gloves are used for the safety of the operator who does welding. They are used to protect the hand and eyes of the welding operator from radiation and heat of the flame. Working of gas welding. At first, all the equipment of gas welding is fitted properly and carefully. After that, a regulated pressure of gas and oxygen supplied to the torch where they are properly mixed. The mixture of fuel gas and oxygen is then ignited by the striker. Then the flame of the torch is controlled by different valves present in the welding torch. Based on the type of flame required, the valves are operated accordingly. If the neutral flame is required, then both the valves are opened equally. If the oxidizing flame is required, then the valve of oxygen is opened more. And if the carburizing flame is required, then the valve of the fuel gas is opened more. The flame is set as neutral, oxidizing, and carburizing based on the metal, its thickness, and some other welding conditions. If you want to know about types of flames in detail, the link will be provided in the description of this video. After that, the flame of the welding torch is moved along the line between the two metal plates. Along with the metal plates, a filler rod is also used, which is used to create a pool of molten material that will fill the gap between the two metal plates interface. The filler rod is moved along with the flame. The filler rod is kept at an angle of 30 degrees to 40 degrees, according to the welding technique being used. After moving the flame and filler rod along the line of two metal plates interface, the two metal plates join together because of the melting and solidification of metal plates interface and the filler rod. Advantages of gas welding. 1. It is easily portable. 2. It is very less expensive and very affordable. 3. It can be easily maintained and repaired. 4. It is a very simple piece of equipment. 5. It is self-sufficient and does not rely on other equipment. Disadvantages of gas welding. 1. The metal joining rate is very slow, so the welding speed is low. 2. A skilled operator is required to operate this machine. 3. The power density is low. 4. The heat affected zone is large. 5. Gas welding is not recommended for welding reactive and refractory metals like titanium and zirconium. Applications of gas welding. 1. Used for joining thin materials. 2. Used for joining ferrous and non-ferrous materials. 3. Gas welding is used in sheet metal fabrication. 4. It is used in aircraft industries.
And once you go through the video indicating the various aspects related to the gas welding, you will be able to have some self-assessment through the questions like how does the gas welding differ from arc welding? What are the different system components of the gas welding? How to identify and realize the different types of the flames in oxy-fuel gas welding process, and write the importance of the fluxes in gas welding, and list the typical applications, advantages and limitations of the gas welding. Thank you for your attention.